chapter 2. Okay, today we'll proceed with chapter 2. It will involve a lot of calculation. Okay, follow me closely. Let me know if I go too fast. Okay, if you need me to repeat, just inform me. Okay, so for now, okay, locating roots of single non-linear equation. So we are focusing only to single non-linear, one non-linear. What does it mean by non-linear? What is linear? You should know the difference by now. What is linear equation? Linear is y equals to mx plus c, x power of 1. That is linear. Okay, if x power of 2 and above, that is non-linear. Okay, and also, let's say x power 2 is quadratic. Power 3, and then more than 1. Okay, so that is non-linear equation. Locating roots over here, roots here means, okay, the roots here means the x. Okay, we'll go through the slides. So after this topic, the objective is to introduce you the numerical methods for finding the roots of single equation. Roots here means the x when y equals to 0. Okay, sorry. Okay, we have bracketing methods and open methods. Okay, so bracketing methods, we have graphical method and bisection method and false position. Okay, graphical, later on you will be introduced into plotting the graph to find the root. Okay, again, as I mentioned, root is x when y equals to 0. Okay, so that means in the graph, y equals to 0. This is y-axis. This is x-axis. Okay, so let's say you are given a non-linear equation, perhaps something like this. So when y equals to 0, here you will have 2 roots. X. Okay. Let's say you have something like this. So when y equals to 0, so this point is your root, meaning x. XR, usually you will find XR. XR refers to root. Okay. Okay, and y over here, y-axis, most of the time you will see it use fx, function of x. So fx equals to y-axis. Okay. I need to introduce you the term first. Okay, so for the graphical method, we will find the XR using graph. You will need to plot a graph. Okay. For bisection, this one using formula. You will be given the formula. False position also using formula. There are 2 different formula for bisection and false position. Okay, this is bracketing method. What does it mean by bracketing? Means you will be given a lower value and upper value. The lower value usually will be denoted by XL, upper value XU. Okay, bracket. You have bracket, so you have something inside. You will be given a value or a range. Okay, range. Let's say for the graphical method, you will be given a range. For example, lower value is 10, upper value is 20. So you must find the root in between this value. Okay. Bisection, it involves cutting into halves. Later we will go into details. Okay, so false position and bisection, both formula will be given. Okay, now, okay, I just introduced, apart from bracketing methods, we have open methods. Open methods, all of this is iteration method. Bisection and false position also iteration. That means you will need to do iteration using the formula given until you get a specified value. Either it will be given, the question will give you, do the iteration until ES equals to 2%. So you must do the iteration. No matter how many iteration, as long as the ES below 2%. Okay, or otherwise, the question will give you, do until 5th iteration. Okay, so the question will guide you when should you stop the iteration. Okay. Now, open method, it doesn't give you the range. You will need to identify. Okay, so I'll start with the graphical method. For this slide over here, I will go back later after we do the graphical, because this slide, it shows you how to get to the final equation over here. Okay, it derived from the statement to get the final equation. Now, we will be using this equation for the graphical method, bisection and false position method. Okay. Now, for graphical, we straight away do the example. Can you see? If I use yellow, let me know if you cannot see. Example 1. Okay, from the given equation just now, y equals to okay, locate the root. Okay, let me confirm the equation. Okay. So this is the question. Given the equation, y equals to that, then it asks you to locate the root. Okay, locate the root means the XR, which is between 10 and 20. So 10 over here is XL, lower value, so XL. 20 is XU. Okay, this one, by right, the question should mention using graphical method. Okay, using graphical method. Okay, now get the info. Those are the infos that you need to know. Now, to answer the question, step 1, identify the range XL, XU. So your root is in between the XL and XU. So XL is 10, XR 20. Okay, so how about the Y? YL, when XR, the value of Y is 0. Okay, remember the root is when Y equals to 0. So later on, we will need to find the YU as well. Okay, so try to calculate what is the Y value when XL equals to 10. Here, using this equation, plug in the X over here with XL value to find the YL. Plug in with XR value to find the YR. Okay, try to calculate. Okay, what you get for YL? .0135. Okay. In your calculation, always use 4 decimal point first. So YL is positive, 0.0135. YU correct. Negative 0.585. Okay, you see the different positive and negative. Lower, you will have positive value. Upper will have negative value. So it cross the zero line. That is when you need to find the XR. Okay. Now from there, step 2, you will need to find the value in between the lower and upper value. Your lower value is 10. Okay, this question, it doesn't give you the step size, right? No info on the step size. So let's say if it doesn't give, you can assume. Let's say we assume step size is 2. This is XL, XU. Okay, we know that YL you have calculated earlier, which is positive. XU negative. YU is negative. Okay, so your XR lies between this figure. Okay, now we need to calculate the Y value so that later on you can plot the graph. Now please calculate each of the Y value over here from 12 to 18. Aiman, who's Aiman? Okay, what you get for 16? Correct. Positive or negative? Okay, at 16, still positive. Brandon, have you calculated for 18? What you get? Come again? Negative 0.29. How about Abdul? The correct one is negative 0.0389. Okay, this is what I get. 0389. Okay, roughly you should be getting around this figure. Brandon, just now you get negative 0.3. Is it? Try to recalculate. Okay, 0.0389. Now we can see now the change of sign is at 16 and 18. Okay, so between 16 and 18. So XR must be in between these numbers because it already crossed the 0 line over here. Okay, Y equals to 0 somewhere over here. Y equals to 0. Okay, now step 3. Now we plot the graph. In exam, you will be given graph paper, but now we just do freehand. Okay, plot the graph in between 10 to 20. X. I will start 10 over here just to make it easier. So Y equals to 0 this side. This is Y. This is X. The largest is at X20 negative 0.58. Okay, so it will go down further lah. Now, try to plot the graph. At X equals to 10, it is 0.0135. So somewhere here. Somewhere over here. Okay, then 12, 0.0122, 122, somewhere over here. 14, 0. Something here. 16, over here. Okay, now 18, it moved to negative side. It should be 4. 18, negative 0.03. Okay, somewhere here. 20 is way beyond. Okay, now we try to plot the graph. This is freehand, so something like that. Okay. Now our x root falls at this point when y equals to 0. Okay, the cross point over there. So what do you think the XR value over here? What? 17. The rest? 16.8. Max will be 17. So from here, from this freehand lah. Okay, here I would say 17 over here. So lesser than 17. Okay, as you mentioned, some of you mentioned XR, it can be 16, perhaps 16.7 up to 17. Okay, so for graphical method, your XR value may vary according to the graph that you plot. Okay. As long as it is in the range, your answer can be accepted. Okay, if you try to plot the graph, then your XR is 19. That one is totally wrong. Okay. Okay, any question so far for graphical method? No question, Clear? Okay, this is the previous final exam question. Is it too small? Can you see now? Aiman, can you see the question? Can? Okay, this is from last year. Okay, here, sorry. For the previous question just now, for the example, straight away it gives you the equation and the range, upper and lower. Now, the final exam question, it won't be so straightforward. It will give you a statement or something like this. So figure 1 shows the cylindrical tank with water outlet at the bottom of the tank. Okay, the velocity of water is V. Discharged from the tank through a long pipe that can be computed as this. So this is the equation that you will need to use. Just now the equation is simpler. Okay. The example is for you to understand the concept. Now this is the equation that you need to use. The figure over here shows the tank diagram. Okay, it gives you the info. G with this value. H is the initial head. L is the path length. T is the elapsed time. Okay, so using the initial gas of XL0 and XU2. So now your XL is 0, XU is 2. It asks you to compute the head required to achieve V equals to 4 in 3 seconds for 5-meter long pipe using the following method: graphical and bisection. Okay, we proceed with the graphical first. Now, this is the equation. Tan H. Okay, what is tan H? Not the normal tan. What is tan H? Okay, we'll see later. Okay, this is the equation that you need to use. Now, it gives you already the figure, few of the infos. G is 9.81, all of this. Okay, all of this we plug in into the equation because it already given. Okay, V is given. It asks you to find the head. Head is the H. So now this H is your X, the one that you need to find, XR. Okay, the XR when V equals to 4. Okay, we plug in into the equation. In 3 seconds, so T replaced with 3, 5-meter long pipe, the L. Okay, so replace all the infos that been given. H is the one that you need to find. Okay, replace all infos. This is first step. We need to find out the equation that will be used for your calculation first. Now, once you get, you replace all the infos, this side should be, okay, the 4 over here. Remember, our XR is when Y equals to 0. Okay, so 4 bring to the other side so that the Y is equals to 0. Okay, so rearrange the equation. 4 bring to the other side. Okay, so this is the final equation. Okay, this is the equation that you will use in your calculation. Up to that step. Any question? In the previous example, it straight away gives you the equation, straightforward equation. Wait, I go to, okay. Here it gives you the equation over here. So you just use this equation in your calculation. In this final exam question, you will need to rearrange your equation first. There's mark over there for the equation rearrangement. Okay. Now from here, it already gives you the range XL and XU. Okay, so wait, this is step 1. Now step 2, find out the x and y in order for you to plot the graph. So in between 0 to 2, stepwise, it gives over here 0.5. Okay, so you find out the x and y value. X low is 0, upper is 2. So stepwise 0.5. So your x, you want. Okay, so 0, 0.5, 1, 1.5, and 2. Okay, find out what is your y from x0 to x2 using this equation. Okay, x over here is your h. Okay, x over here is your h, the one that you need to find out. Find out the y value for this range. Later, you will need to plot the graph and find the xr when y equals to 0. Yes, Aiman? Come again? Substitute to the x. The h here, tan h here. H here is hyperbolic, not the x. Tan hyperbolic. Okay, as of now, we just use the normal tan first. Okay? We just use normal tan first. Let's say we just use normal tan first. Tan h is tan hyperbolic. Okay, let's remain as tan. As of now, we ignore the hyperbolic first. Okay, try to calculate your y. Okay, if using tan, can you get the change of the sign or not? No. All positive or all negative? All negative value. Similar. No change of sign, right? Okay. So that's why it is important for you to use the correct mode. Okay, now we use tan H. Later you compare your result. When using tan hyperbolic, the function that you need to use in your calculator, this one using 570, bracket hyperbolic HYP. Can you see HYP? HYP, see? Okay, press the HYP, then you press the tan. Appear not? Tan H. Appear? Okay, so use that function. Try to recalculate. If you use tan H, there is change of sign in your Y value in between 1 and 1.5. So after that, you plot the graph. From the graph, when the line cross the Y0, that is your X root. Okay, try to plot the graph using freehand only. What you get for y x0? Okay. Negative 0. Okay. Negative 4. 0.5. 6, 9, 7, 8. 1. 0. 1.5. 2. 2. 2. Oh, sorry, wait. Sorry. Okay, for 1.5 again, 0. Come again. Negative 1.0. 1.5. 1.019. Okay. 2. Okay. So we now you see it's between 1.5. Sorry, 1 and 1.5. So your x root lies over here. Plot the graph. Then you will get the figure. So what you get for your XR? Perhaps 1.2. Okay, 1.2 around there lah. 1.2, 1.1. Okay, it should be in between 1.1 to 1.2, roughly. Okay, so for the graphical method, in this question, it brings you 9 marks. So the 9 marks contribute by the rearrangement of the equation over here. The rearrangement, you plug in the infos into the equation, you'll get marks. You rearrange, make it y equals to 0, you will get marks over here. So after that, for step 2, show all this table and values for the step size and for the y value. Each of these will get marks. Okay, each of the figures will get half marks usually. Now from step 2, move to plotting the graph. The correct value, correct axis, you'll get marks as well. Correct plotting, you'll get the marks. Then you should show this is your XR. Then the XR value, marks for XR value. Okay. So final exam question, expect something like this. It won't be a straightforward question. You need to figure out what is your X, what is your Y. Okay, in this equation, there is no X and Y. The term used is V and H. Okay. Can I? Any question? Anyone need me to repeat? Okay, if no question, I proceed to the next one because we still have time. This is the example of the previous example 1. Okay, so it plot the graph. This is the root that it get. Now I move to bisection method. Bisection. Bisection is you cut your you will be given the first XL and XU value. Okay, so bisection, those range later on you will cut into half. Okay, for example, this is the range for the first range. For example, 15 and 17, the first range. The next range you need to find out using the equation for bisection, then cut it. You make it into smaller range so that XR, the range is approaching the XR. Okay, so this one, we will use equation. There is no plotting graph. Okay, the important part that you need to identify is XL and XU, whether it is given or not. If it is not given, you should ask for the value. Okay, you need this value. Okay, if let's say if it is not given, perhaps the previous question you will need to find the figure. Okay, because in midterm September, you will need to find the range. Later, that one I will share in the next class. Okay, basically the bisection, you will need to fulfill this. FXL multiplied by FXU must be below 0. Okay, then from here, if it meets the requirement, then only XR is exists. Okay, XR is exists. Let's say you try to find, your XL and XU. And then your FXL multiplied by FXU more than 0. So it doesn't meet the requirement. You must check your calculation. Okay, first thing, it must meet this requirement. FXL multiplied by FXU below 0. That means negative value. Okay, FXU over here, because later on you will see FXL multiplied by FXR. Okay, this is the first requirement for bisection. Now this one, once you have the XL and XU. Okay, this one you check. If checked, then the root exists. Negative value, root exists. Then step 2, you must estimate the root, the XR, by using this equation. We have the value of XL and XU in order to find the XR value. Okay, approaching the XR value. Okay, I explain first, later we do exercise so that you can understand further. Now, after you calculate the XR, you identify the XR, then you need to check FXL multiply FXR. Okay, here is XR. Negative value, so the XR is set for the new XU. Okay, I explain first, later we do. If the FXL, FXR positive value, the XR is the new XL value. Okay, if FXL multiplied by FXR equals to 0, then that is the XR value. You should stop by here. But if you, usually the question will give you the stopping criterion, whether ES or the amount of iteration. Okay, we'll go through the exercise. Okay, this one, using the previous exercise, the example 1, the same equation over here. Solve for XR using bisection method until the pre-specified error is 2%. Okay, this is your stopping criteria. ES equals to 2%. So you must find out, later on, you must find the EA until below 2. Okay, now we move to this equation, to this example. Where is it? Wait, I changed to yellow. Now we identify the equation first, which is this one, as previous example, same. Because later we can compare the XR from using different method. Okay, now we need to do the iteration. Okay, follow me closely. Iteration, this is the one that you need the info. XL, XU, FXL, FXU, XR, FXR, then the EA in percent. Okay, these are the values that you will need to determine for each iteration until you get the EA below 2%. Okay, I forgot to write here. ES is 2%. Okay, for the first iteration, XL is the one that is given. 10. XU is 20. Okay, so what is your FXL? That one has been calculated in example 1 just now. FXL for 10, the sign is positive. Okay, correct? Huh? This one, the one that you calculated earlier. Now, FXU is negative 0.585. Okay, now XR using the bisection equation. XR, the equation is XU plus XL over 2. So this is the equation that you need to use to find the XR. Okay, now for the first XR, what is the value? Okay, 15, correct. Now find the FXR. You should get positive value, which is 0.0062, correct? Yeah. EA, how about EA? Any value for EA? No value, correct? Because EA is current approximate minus previous over current. Now we don't have previous. So first one EA is 0. Nothing. Now, what we need to see is from this FXL multiplied by FXR. If negative, the XR is the XU. Okay, now FXL and FXR, positive or negative? Multiplication, FXL multiplied by FXR. Positive, right? So positive, the XR will be positive, XR will be the new XL. So this XR will be the new XL for the second iteration. XU remain. So FXL is the F for 15, the previous FXR over here. Positive. FXU remain. Now we find the new XR. Correct, 17.5. Find the new FXR. Negative, is it? Okay, you will get negative 0.0201. Okay, so for the second iteration, you can find the EA. So what is the EA? $14.29, is it? The EA. Okay, EA over here refers to the XR. Use the XR value. Current minus previous over current. Current minus previous over current. The EA. Then multiply by 100. What you get? 14.29. Okay, here you should be getting 14.29%. Okay, now check whether the XR should be the new XL or XU. When FXL multiplied by FXR. So positive or negative. It will be negative, correct? So negative, the XR will be XU. Okay, so 17.5 now will be XU. XL remain. Find the new XR. Should be getting 16.25. Okay, I go faster a bit. We are approaching 9:30 already. Okay, here you will be getting this figure. The EA for the third iteration is 7.6%. Now the new XR will be the new XU because it changed XL, FXL, FXR multiply, you will get negative. So the XR will be the new XU. Okay, for the fourth iteration over here, with the new XR, the FXR you will get positive. Now FXL multiplied by FXR positive. So the XR will be the new FXL as the new XL. Okay, for the fifth iteration over here, you will get your EA 1.96. Okay, you can stop here because it already made the criterion, ES 2%. So 1.96 is lower than 2%. So we can stop at fifth iteration where this 935 is your XR. Okay, so this is your XR. So to conclude, root is this figure with EA equals to 1.96%. Okay. I will repeat again this example in our next class. Okay, and we do more exercise. We proceed the final exam question just now on the bisection. Okay, so that's all for today's class. Before you leave, please sign here.